Hi, welcome to our assembly. It's the Wednesday of our maths week. So you've been doing lots of really exciting stuff in class. You've been learning lots of cool maths, and you've been finding out some really fun stuff about number, about shape, about statistics, about all sorts of other things. And on Monday, I showed you a cool magic trick to do with numbers. I wonder if anybody has tried that with their parents at home. See if anybody's mums and dads thought that you were actually magicians, maths magicians, because we know that maths is really, really cool. So what I'm going to do today is I'm going to show you a number sequence and some patterns and how we see those numbers in nature all around us, because that's really important. That actually maths is out there in the world right now. And then I'm going to read you a story, which is just like a good story, because we know that stories are really, really cool, and we love books at Wincham, don't we? Right. Okay, here we go. Let's have a look at this number sequence. Share my screen with you. Okay. This is a number sequence that was discovered by a guy called Fibonacci. He was also called Leonardo of Pisa, and he was an Italian mathematician. He was born around about 1170, which is nearly 900 years ago. Okay, and the number sequence goes like this. It goes 1, 1, 2, 3, 5. I wonder if you can tell me what the next number in that number sequence is. I wonder if you can see if you can work it out. What do you reckon? I'll give you some clues. I'll give you some help with it, because it's a difficult one, and I don't want to spend all of your time with you guys guessing and me not being able to hear what you're saying. So the next number is 8. See if that gives you a clue. And the way it works is that you take the number and you add it to the number before. So with this one, the number before is 0. So we've got 0, add 1, and the answer is still 1. But then with the number 1, we get to add 1, because that's the number before. So we get 1 add 1 is 2. And with 2, we get to add the number before. So we add 1 again. And 1 add 2 is 3. And then we add 2. And 2 add 3 is 5. So then we add 3. And 3 add 5 makes 8. And then we add 5, and 8 add 5 makes 13. And then we add, what do we add? That's right, we add 8, and 13 add 8 makes 21. Okay, and then we add 13, and 13 add 21 makes 34. Well done, very good. Right, and we can carry on that number pattern. Now, the interesting thing is that when you turn that into a slightly different way of looking at it, it looks like a really cool pattern. So if you remember, we had a sequence that started with 1 there, and then 1, and then 2. So you can see there we've got 2 squares, okay? And then 3, so there we've got 3 squares, and then 5, there we've got 5 squares, and then 8, we've got 8 squares there, and 13, we've got 13 by 13, and 21, and we've got 21 by 21. And if we make a square, so a 1 by 1 square, and a 2 by 2 square, and 2 by 2 square there, and then a 3 by 3 square, and then a 5 by 5 square, and then an 8 by 8 square, we can draw that spiral round. And there's loads more maths that we can do about this. And I'm showing you this really, 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 really super speedily to show you that this spiral shape is actually based on a mathematical sequence, on a number sequence. Okay. Now, I wonder if you've seen that spiral shape anywhere in nature. What do you think? See if where have you seen that spiral shape? See if you can tell your partner if you might have seen it. Okay, tell your teacher. Right, I've got some examples. Now, in each of these cases, there is a spiral on one of these natural shapes that is exactly the same as the spiral that we've just seen. So we've got this shell, and I can draw around there, and you can see the spiral based on our number sequence. We've got a sunflower, and the spiral, very badly drawn there, is shown there. We've got a pine cone, and the pine cone is showing that number sequence there. We've even got the pattern in a hurricane, and you can see there that it makes that spiral in the same way, and that spiral is shown here in a galaxy in the stars as well. So lots of different ways that number sequence makes a spiral, and that spiral is shown in nature. It's really, really cool. So that guy was Fibonacci, or Leonardo of Pisa, and you will probably do lots more work about the Fibonacci sequence when you get a little bit older. You might do some of it in primary school, you might do some of it when you're at high school, and it's dead interesting to find out about because it's absolutely everywhere. So when you see a spiral like that, remember that you can think that that is based on some numbers. Okay, so there you go. That's just really interesting that you've got numbers there. Now, what I'm going to do is, I said I would read you a story. So let's find the story for you today. Okay, because we love reading books, because stories are really, really good. So this story is called Equal Schmeequal. And now we've got a bear and a mouse and some bees. Okay, so equal is a really important maths word. So we're going to read a story about things being equal today. A little brown mouse sat under a leaf watching a school picnic. The children finished eating and began to play. Some played tag, some chose teams for a game. The two sides have to be equal, one of them shouted. The children pulled on the ends of a rope. One team was pulled over a line, and the other team cheered, "Hooray, we won, we won!" Then one of the teachers called to the children. They all got into a big yellow bus that drove off down the road. All was quiet. That looks like fun. "Hey, Bear," called Mouse, "come out and play." Bear walked out from the trees. "What do you want to play?" "It's a game," squeaked Mouse. "You take one end of the rope and I take the other. We both pull to see who wins." Bear gave the rope a mighty yank, and Mouse flew across the field. She landed on the ground with a thump. "Hey," said Bear, "where did you go?" "No fair," squealed the mouse. She picked herself up. "I forgot that teams have to be equal." "Equal schmeequal," said Bear. Suddenly, sharp claws grabbed Mouse. It was Bobcat. "Gotcha," he snarled. "Help!" squealed Mouse. Bear stood up on his hind legs and growled, "Let Mouse go right now." Bobcat whimpered, "I just want to join the game. See, Wolf's right here. He wants to play too." Wolf stepped out into the open. Mouse brushed off her fur. She said in her bravest voice, "Of course you guys can play. Everyone can play as long as the teams are equal." "Equal schmeequal," said Bear. He reached into one of the trash cans and pulled out a half-eaten sandwich. Rabbit hopped into the field. "Can we play too?" Rabbit asked. Box Turtle plodded close behind. "What does equal mean anyway?" he asked. "Equal means fair," explained the mouse. "We should divide into two equal teams somehow." What did Bear say? "Equal schmeequal," Bear mumbled with a mouthful of chocolate cake. "Let's try meat eaters against plant eaters," said Rabbit. "Oh, carnivores against herbivores. That would be fair." "What about Turtle and me?" asked Mouse. "We eat anything small enough." "Well," said Rabbit, "what are your favourite foods?" Mouse replied, "I like blackberries best." "I eat mostly bugs," said Turtle, "but my favourite food is dandelions." "Well, if you like plants best, you belong on my team," said Rabbit. "So it's animals that eat only meat against the rest of us." Bobcat laughed. "You think this is equal? Ha!" With just one hard pull, he and Wolf yanked Mouse, Rabbit, and Turtle across the line, and they landed in a heap. "That wasn't equal," Turtle complained, peeking from his shell. Bobcat said, "Everyone with fur go to one side. Everyone without fur go to the other." But that left only Turtle on a team, and that couldn't be equal. "Does anyone know what halves are?" Rabbit asked. "I've heard the farmer talking about halves." "Halves are what you get when you make two groups with the same number," Mouse said. "We can't make halves because there are 5 of us." Just then, Mouse saw hooves behind a bush. "Hey," she said, "maybe Deer will want to play. Then we can make halves." Deer slowly stepped out of the woods. It looks like fun, she said, but I want to keep an eye on Wolf and Bobcat. I'll pull from behind them. The animals lined up, 3 on each side. 3 on one side, 3 on the other. So it's equal because we've got 3 is half of 6. They pulled, but once again, Mouse, Rabbit and Turtle were easily dragged over the line. No fair, complained Rabbit. They're all big and we're all so small, so it isn't equal at all. You're right, said Mouse. The numbers are equal, but that doesn't make the teams equal. What did Bear say? Equal schmequal, Bear exclaimed, finishing off a piece of pizza. The animals scowled at each other. Everyone began talking at the same time. It's no fair, you're so much bigger. You're just mad because you lost. You don't care if the teams are equal as long as you win. Mouse sat by herself and tried to think of a new idea. She tapped a tiny foot and twirled a wiry whisker. Listen, said Mouse. Listen up, she said louder. I have an idea. The animals stopped fighting. Well, asked Bobcat, what's your great idea? I thought that instead of equal numbers, she explained, our teams could have equal weights. We could use the seesaw to figure it out. Look, said Mouse, when what's on one side of the seesaw is equal to what's on the other side, the seesaw balances. You can tell because it's straight across. Okay, said Turtle, let me get on first, because I can't jump. He walked onto the end of the seesaw, touching the ground. I'll get on the other side, said Wolf. Wolf jumped onto the centre of the seesaw and made his way to the end. Turtle was lifted high into the air. He looked down the long way to the ground and tried not to be scared. Deer got up on Turtle's side. Their side sank down and Wolf rose into the air. I'm next, shouted Bobcat. He got onto Wolf's side, but Wolf and Bobcat together were still up in the air. With a mighty hop, Rabbit landed in front of Bobcat, and now the seesaw was almost balanced. Come on, shouted Rabbit, you're the last one, Mouse. Mouse scampered up next to Deer. The seesaw teetered back and forth before resting perfectly straight across. The teams were balanced. We did it! We're equal, Mouse squeaked. Then Bear looked up from his crumbs and ran over, roaring, Wait for me! He jumped on, and down went his side of the seesaw with a bump. Deer, Mouse, and Turtle went flying into the air. Oops, said Bear. I guess it's not equal anymore. We can get this right, Mouse said cheerfully. Let's try again. Bear, get on first. Bear sat on one end with the other end high in the air. Bobcat offered to get on the high side first. If I fall, I'll land on my feet. Cats always do. The rest of the animals got on. Each one made Bear's side lift a little. Finally, all the animals were on except Mouse. Come on, shouted Rabbit. We're almost equal. Mouse jumped onto the middle of the seesaw. Bear's side was higher, so she walked towards him, and the seesaw was perfectly balanced. They jumped off one by one and picked up the rope. Bear and Mouse were on one side of the line, and all the other animals were on the other. Okay, said Mouse. Now the teams have equal weight. Whichever team pulls the other across this line wins. Bear and Mouse pulled. Turtle, Rabbit, Bobcat, Wolf, and Deer pulled back. I'm bigger than all of you, said Bear. I'll win. Come on, said Rabbit to her teammates. There are more of us. Pull harder. They pulled and tugged, but neither team moved an inch. What if no one can win? Asked Rabbit. Suddenly they heard a loud buzzing overhead. Bees! Shouted Bear. There must be honey nearby. He took one paw off the rope to point at the swarm of bees, and just then the other team gave a mighty pull and Bear stepped over the line. Hooray, said Rabbit. We won, we won. But the teams were equal, said Deer. How did we win? What really matters is equal effort, said Mouse. When we all pulled our hardest, the effort was equal. That's why no one could win. But when Bear saw the bees, he forgot to pull, and the effort wasn't equal anymore. Equal schmequal, said Bear. I want some honey. Mouse laughed. Time for a honey break. The animals followed the bees to their hive in a tree. There was more than enough honey for everyone, and they shared it equally. So what it means to be equal. So in maths, to be equal means that to have parts that are the same weight or size or quantity or other measure. And in art, you might have been looking at symmetrical patterns, which means you can draw a line through the middle of a picture. And one half looks just like the other half, just like the really cool pictures in Oak's class, they're portraits. In law, equal means having the same opportunities, rights and privileges. Okay, just like we talk about our global goals of gender equality or reduced inequalities, which is where taken from that word equal. And in sports, team sports players, teams have got to have this equal numbers, and all the players have to give their best effort to have the best chance of winning. There we go, guys. It's a good book, that one. I like that. It's a nice story. So things have to be equal, things have to be fair, and that word equal comes across in lots and lots of different ways. And we've been talking about something to do with maths every time we've talked about those global goals of gender equality and reduced inequalities as well. Okay, have a lovely rest of the day, and just like the animals in the tug of war, try your hardest at everything that you do, work really hard, and I will see you around school. Bye-bye.